So here's some more chain rule problems. This time we have actually 3 layers of our chain rule as opposed to 2. So I'm going to try to use some color to help us illuminate what we're doing here. So it's just y equals, the outermost function is the squaring function. So we'll just use blue for that. So it's everything being squared. The next function is the secant. And then the next function is the 5x. So derivative of the squaring, the secant, then the 5x. So let's just rewrite the derivative of y with respect to x is equal to, so now we're going to do the blue function, which is 2, leave the inside alone. Two minus 1 times the derivative of the inside. So derivative of the inside is just the middle piece, which is the red part. So derivative of that is just the secant, the tangent. So secant tan is derivative of secant, and we just leave the innermost piece the way it is. Then we multiply by the derivative of the green, which in this case is the innermost piece, which is just 5. So now we just pull everything together, multiply the 2 and the 5, and rewrite the secant. So our derivative is 10 secant 5x times secant 5x tangent of 5x. These two are the same, so we can multiply them and square it. 10 secant squared 5x tangent of 5x. Our next function again has 3 pieces. So I'll rewrite the function using some color. Our function is y equals, our outermost piece is the raising to the negative 2. The inner function is 1 minus the tan. And then the innermost piece to that is the 2x. So we have 3 layers to our chain rule, the negative 2, the tan, the 2x. So now when we take the derivative, we get dy dx is equal to the derivative of the blue. So this negative 2 comes down. We subtract 1 from the exponent. We rewrite the inside piece as is. 2x times, we now take the derivative of the red function. So derivative of 1 is 0. The derivative of tangent is secant squared. So it's negative secant squared. The green function stays there. Times the derivative of the innermost piece, which is 2. So my final answer is dy dx. This is positive 4, the negatives cancel, and 2 times 2 is 4. I get 4 times secant squared 2x. All over, I put this in the denominator just to make it look more attractive. And there's our derivative. Here we have 4 functions actually. So we start off with y equals, the outermost function is the square rooting. So I'm going to write that as the 1/2. Then we have 4 plus the cosine squared. So that's 4 plus this item squared. Then we have the cosine of 5x. 5x. So we start off our derivative, dy dx. Derivative of the outside, put the 1/2 up front. Rewrite the inside. And then that inside. And then that inside. Times the derivative of the next layer, which is 4 in the squaring. Well, derivative of 4 is just 0, so it's the derivative of the squaring piece, which is just 2 times the inside, raised to the first power, subtract 1 from 2. So you get the cosine of 5x. Then you take the derivative of the next layer, which is cosine 5x, which is times negative sine 5x, times the derivative of the blue, which is just 5. And this is to the negative 1/2 power. So therefore, we need to simplify. I can do the half and the 2. I'm going to pull this 5 and put this down in the denominator, put the 5 up front. So we get dy dx. I'll put this all over 4 plus cosine squared 5x to the 1/2 power. And those two cancel, so I'm left with negative 5 cosine 5x. I like that in parentheses. And sine 5x. Okay, our next one is 1, 2, only 3 values here. So let's rewrite it using some of our colors. Our outer function is the cubing function. The next function is the sine function. And then the next function is the squaring function, x squared. So when we take the derivative, we take the derivative of the blue, or the 3, so the coefficient comes, the exponent becomes a coefficient. Subtract 1 from the exponent. Rewrite the red function and its inside. Times that by the derivative of the red, which is cosine of its inside, times the derivative of its inside, which is 2x. So we just change the order a little bit and we're all set. 3 times 2x is 6x. I'm going to put the cosine x squared up front. So it's cosine x squared times sine squared x squared. Here's our last example. This one again only has 3 layers. So let's rewrite the problem as y equals. Outer function is tan. Then the next layer is cosine. And the final layer is 3x. So we take the derivative of tan of x is secant squared cosine (3x) times the derivative of the red function, which in this case is cosine, is negative sine 3x times the derivative of 3x, which is just 3. So we rewrite our answer. Negative 3 sine 3x times secant squared cosine 3x. Hope you enjoyed that.